The entries in our table contain the sum of the two dies. For example, in this square, die 1 was a 5 and die 2 was a 3, so the box contains 5 plus 3, which is 8. To complete our table, we can fill in the blanks by adding together the numbers on the two dice. In this square, we rolled a 1 and a 6, so we should write in 1 plus 6, which is 7. Here, we had a 2 and a 5, so we'll write in 2 plus 5, which is also 7. In this box, we had a 3 and a 4, so we'll have 3 plus 4, which is 7. Here, we had 4 and 4, so we'll have 4 plus 4, which is 8. In this box, we had 5 and 5, so we'll have 5 plus 5 is 10. Finally, over here, we rolled a 6 and a 6, so we'll write in 6 plus 6, which is 12. In part 2, we want to find the probability of getting a total of 7 or 11. We should think about both these cases. Starting with the 7, we have 1, 2, 3, 4, 5, 6 boxes in our table that contain 7. So there are 6 ways we can end up with a total of 7. When we focus on getting a total of 11, we'll see that there's only 2 squares which contain 11. So there are 2 ways to get an 11. If we want the probability of 7 or 11, we should combine these scenarios by adding. Together, we have 6 plus 2, which is 8 ways to get a 7 or an 11. Our table contains 6 rows and 6 columns. This means that the total number of entries in the table will be 6 times 6, which is 36. So, there are 8 ways to obtain what we want, a 7 or 11, out of 36 total possibilities. So our probability here is just 8 over 36. In the next part, we must find the probability of getting a prime number as our total. Well, a prime is a positive whole number which has exactly 2 divisors, 1 and itself. The numbers in our table range from 2 all the way up to 12, so we should consider which numbers are prime in this range. 2 is a prime. 3 is also a prime. 4 is not a prime since it is divisible by 2. 5 is a prime. 6 is not a prime since it is divisible by 2. 7 is a prime. 8 is not a prime since it is divisible by 2. 9 is not a prime since it is divisible by 3. 10 is not a prime since it's divisible by 2. 11 is a prime, and 12 is not a prime since it's divisible by 2. So the prime numbers between 2 and 12 are 2, 3, 5, 7 and 11. Just like the second part of the question, we can count up the number of ways we can get each of these numbers, and then add all these up to find the total number of ways to land on one of these. There's just one way we can end up with a total of 2. There's 2 ways to get a 3, 4 ways to get a 5, 6 ways to get a 7, and 2 ways to get an 11. Adding all these up gives us a total of 15 ways to get a prime number. As we saw previously, there's 36 entries in the table. 15 out of these 36 are prime numbers, so our probability is 15 over 36. Given a car, this question focuses on two properties of that car. Is it a Ford car or a Renault car? And is it a red car or a not red car? Let's break down the different combinations. We know that we have 18 Ford cars and 12 Renault cars. 7 of the Ford cars are red. Since 18 minus 7 is 11, the remaining 11 cars must be not red. We know that 4 of the Renault cars are red. Since 12 minus 4 is 8, the remaining 8 must be not red. We are interested in the probability of a Ford car or a car which is not red. As long as our car satisfies one of these properties, then we're happy. If it satisfies both, then all the better. We had 7 Ford cars which are red. Since these are Ford, we'll want to include them. We had 11 Ford cars which were not red. This satisfies both our properties. It's a Ford car and it's not red, so we'll want to include these. We have 4 Renault cars which are red, and this does not satisfy either of our properties. It's a Renault car, not a Ford car, and it's red, so it isn't not red. We won't want to include these. Finally, we had 8 Renault cars which were not red. Since these are not red, we will want to include these. So, we have a total of 7 plus 11 plus 8, which is 26 cars being Ford or not red. We know that there was 30 total cars in this scenario. Since we have 26 out of 30 of the cars being Ford or not red, our probability is 26 over 30.